I'm going to show you how to find the slope from graphed coordinates in the graphing sticky of Classpad.net. So I'm going to pull up a graph sticky. That's this second one here. And I'm going to enter a function. Let's say a typical problem students might have is they're given a linear function, but in standard notation, and they're asked to find the slope. And a lot of times they get a little confused with that. So let's just enter a function here, and I'm going to enter it in standard form. So ax plus by equals 0, plus c equals 0. So let's say this is it. And the nice thing about Classpad is you can enter it in any form, standard form, slope, intercept, point slope, those types of things. So when I hit execute, it's going to graph that. So notice that I can see the slope is going to be negative, right? So students have some idea of slope, but I can't see the intercept. So how do I do that? So I wanted to point out that when you click on the function itself, so once you've graphed it and you click on it, you're going to get some key points, and we can't see the slope. Yes, I could zoom in, but I'm really trying to focus on helping students use coordinate points on a graph to help them find slope. So notice that this is a key point, but I don't want to use that point. Let's just click somewhere else, and it brings up a second point. And maybe we want to point down here. So anytime you click on the graph, you get points that you can move, and they are anywhere on that. So that's a really nice feature for students. Now, I did want to point out that Classpad.net has standard forms, so they're in standard notation right now. If I want students to work with that, that's fantastic. Let's do that. Or I can go into the settings of the graph, so these 3 dots, and I can actually change my coordinates to be decimals. Up to you, however you're working with students. I always think it's nice to work in standard notation, but let's just go to decimal right now. So you'll notice that those points are now in their decimal equivalent form. What I want to do is I want to basically define these points as my point 1, point 2, or my x1, x2, y1, y2. So to do that, I'm going to double click the point, and so notice what happens. I get this little kind of highlighted label with an X, and so I want to do the next one here. And once I've done that, when I right click, there's a couple options. I can convert those points into a table, so that's a nice feature if I want to do that. Or I can show the label, and what this is doing is assigning those points, and they're usually based on how I chose them, but it's assigning those points to be point 1, point 2, and if I had another one, it would be point 3, and it would go on for however many points I had. But now the coordinates are going to be identified as x1, x2, y1, y2. So for example, point 1 here, this x coordinate, negative 1.2, is really x1, and this is y1, and this is now x2 and y2. So whatever the point label is how my coordinates are labeled. And then that's how I can match to that slope formula that students are hopefully understanding. And we can pull up a calculate sticky. Nice thing about Classpad is things are connected. So I'm pulling up the calculate sticky, even though all of these numbers and values are in the graphing sticky, I'm pulling up a calculator sticky, and I'm going to be able to use those to help me find slope. So most of us define slope as m, whatever variable you're using is fine. So I'm going to say m, and we're going to do a calculation with these coordinates that I've labeled. And because I've labeled them point 1, point 2, I can now use the x1, x2, y1, y2. So how do we define slope? I'm not going to use an equal sign. I'm going to use a define. So if you look here, I have either equal or colon equal. And colon equal basically means define this variable, this word, whatever it is, to be this. And then anytime I use it in the future, it's always going to be defined that way, so I can use it over and over again. So what do we want slope to be defined as? Well, students learn their slope formula, and that's usually y2 minus y1. So we're going to actually use that since we have these labeled coordinates. I do have a y1 and a y2, and I do have an x1 and x2. So I'm going to enter my variable y, and to get the subscript in Classpad.net, so I want y2, right? I want to hit I'm on a PC, so I'm going to hit shift and my underscore key, that's kind of up at the top, And it's going to basically bring me a subscript, and I can then put my 2 in there. And then I'm going to subtract my y, and again, shift underscore 1. So again, remember, because I've labeled my coordinates P1, P2, their x and y's are also 1 and 2. So let's do the x, and again, subscript for me is shift underscore, and then x 1. What's going to happen now, it's going to actually take these coordinates when I hit execute and calculate the slope. So the slope of this line is a -6. Now we looked at it and we knew it was going to be negative, but now we actually have that calculation. So let's then say the students are asked, okay, so you found the slope, excellent. Can you find the y-intercept and write the equation in slope-intercept form? And yes, they could definitely solve the equation for y equals and do it that way. I'm just showing you a different option. So now the cool thing is we can use both these coordinate points and this slope that we just found to find the b-intercept. Let me show you how that works. So let's just, I'm going to pull up this text sticky here. So we know that slope-intercept is in this form, right? So I'm really basically, can I use what I have? So I have points and I now have the slope to find this missing b. Well, if I were to solve for b, b is just a y coordinate, subtract the slope times the x coordinate. And I have 2 points I could use for that y and x. So I'm just going to use one of them. Let's just use P1. So when I go back to the calculate, I'm going to do y, and I want my subscript 1. So y1, subtract the slope I just found, so -6, times, I want to make sure the coordinates I use are coming from the same point, so I want my x sub 1. And I'm going to say equals b, and I can use b as my unknown. When I hit execute, it's going to solve that problem, since remember it actually has coordinates. It's pulling them from my y1, x1, or my point 1, and it's telling me that, oh, your slope-intercept is a -12. So now let's verify. Could I write this equation in slope-intercept form? Let's go up to our equation and add a second one in slope-intercept form using these two values. Slope's -6. Intercepts -12. So it would look like this in slope-intercept form. Y equals -6 times x, either plus a -12 or subtract 12. And if I'm correct, I should now see a red function directly on top of my original blue function. And I do. And we could then verify, we could move our graph up and see if this coordinate here is actually 12, and it is showing that. So lots of ways to verify your things. But this is just a great way to help students really kind of utilize those formulas that we ask them to use. How do you find slope if you know 2 points? And just kind of verify it with both visuals and calculations and function graphing.